I'm John Siau from Benchmark Media Systems, and I'm Director of Engineering and one of the owners of Benchmark Media Systems and designer of many of the Benchmark products. Benchmark, as the name implies, is committed to excellence. Every product that I introduce to the market, it's our goal to be the performance leader in that particular product category. So whether it's a new power amplifier, a new D to A converter, a new preamplifier, when that product goes to market, it will have the lowest distortion, lowest noise, and highest performance of any competing product in that product category. And at any price range. So we're not just looking to compete with a certain price range of products. We want to be the performance leader in that product category. And so we've got a pretty successful track record in doing that. And we've done that with D to A converters, with A to D converters for recording studios, and we do that with power amps and things for home hi-fi. Our products are very specifically designed to be transparent and bring the studio experience into the home, so that you're hearing the same thing that was heard in the recording studio. We want it to be heard without an electronic fingerprint, without being obscured by the electronics, without being changed by the electronics. We want the electronics to be transparent and bring you into the studio, or even bring you into the live performance. One of the things that's unique about our power amplifier is that it has a regulated power supply, and this is very well suited to operation in Japan, where you've got lower voltages, and so we'll put out the full rated power with a 90 volt input voltage, whereas many other power amplifiers, the output power drops as the line voltage drops. And so as you have variations in the line voltage, or if you're in a country that has lower line voltages than the rest of the world, you end up with a power amplifier that doesn't put out its rated power in the Japanese market. And we've got a solution that gives you consistent performance anywhere you plug it in the world. It's one of the advantages of the AHB2. And each of our products are designed to work in a variety of different power systems, but they're also designed to be compact. So, whereas most products are full 17 to 19 inches wide, we've got a lot of our products are smaller and fit into a smaller footprint and easier to fit into your home. I graduated from Syracuse University with a Bachelor of Engineering in Computer Engineering and Electrical Engineering, and I worked for CBS Television in Stamford, Connecticut, in their research lab. One of the things I have 2 patents on image stabilization. So this is built into every phone and every camera these days. Takes the vibration out of when you're taking a video. The patents that CBS had that my name was on, those all expired long before cell phones came about. But that was one of the things that I worked on at CBS. We also worked on high definition television, and so my experience was in digital video and in image processing, and then I took those things and brought them into audio, which was my passion. That's what got me into electrical engineering in the first place, was my love of music and my love of audio. So those are the things that got me into electrical engineering. I went into video and then transitioned from video back into my first love, which is audio. I guess the first small format products that we built for broadcast facilities. We were a manufacturer of audio equipment for television studios, and they had a need for very compact equipment, where they wanted to put a lot of equipment into a small rack, and so that's what initially got us going with smaller products. The other thing is the footprint of some of the smaller computers. So that half rack wide, and some people love the small format, and some people don't. It's a matter of taste, and we've built most of our products on that small format. I always enjoyed the Vio mini notebooks back when they first came out, and remember at the time most of the computers were very large, and I had this little Vio notebook that was about this big that I carry around in a little pouch, and I could flip that thing open, and it was a complete computer with Wi-Fi when computers didn't have Wi-Fi, and it was just a great. I just loved the packaging of that, and that's what Japan has done so well, is the packaging of so many devices, and I always admired that, and I always wanted our products to be compactly packaged in the same way, where there's so many things packed into that wonderful little notebook computer that I had, and I still have it many years later. It sits on my desk. I don't use it because it's obsolete now, but I just like it because it was such a neat package. Every power amplifier needs to have a transformer to step the voltage down from the line voltage to give you your power rails that you're going to need. If you do that at 60 hertz or 50 hertz at the line frequency for a big power amplifier, you're going to have a transformer that's very large. And if you open a lot of power amps, you'll see a very large toroidal transformer right in the middle of the case. And not only is it large, but its magnetic fields are correspondingly large, and so it emits a lot of magnetic interference. It generates magnetic fields that can get into your electronics and cause interference. And if you use a switching supply, the transformers get very small, and the magnetic fields get very small. And in fact, the transformers can be built inside of what's called a pot core, which completely encapsulates the coil. So the emitted magnetic fields are very small. Not only are they small, but they're way above audio frequencies. So they don't, if they get into the audio, they don't cause audible interference. And because the fields are so weak, it's a lot easier to shield against them or keep them out of the audio circuits. So a switching power supply can be much quieter than a linear power supply because of that reduction in magnetic interference. And in the AHB2 power amplifier, we've got a switching power supply right up here on the top level, and 2 inches below it is the amplifier board, and yet that power amplifier has 135 dB signal to noise ratio. Could never do that if it had a linear power supply. That linear power supply would create hum and buzz in that amplifier board just because of its proximity. It also means that you can stack our products up without one interfering with another. HB2 power supply is making sure that the switching occurs at the zero crossings, so that there's not very abrupt current transients that create a lot of interference. So it's quieter than a lot of switching power supplies. The other thing is the switching frequency is selected to be well above audio frequencies. For one thing, you don't want it to make acoustic noise that you can hear, and you also don't want it to magnetically interfere with the audio circuit. We're looking to optimize the signal-to-noise performance, but we put a higher priority on keeping distortion low. We don't want to add distortion to a piece of music that's already been mixed with multiple instruments and multiple voices. If you apply distortion to that, it's not going to be musical in the sense of it won't just be harmonic distortion at that point. You end up with intermod distortion. It's interference between this instrument and this instrument and this instrument. You've got multiple tones coming in at the same time. If you cause distortion, it doesn't end up being harmonic distortion. You get intermod distortion. And so it's very important in the playback software, playback hardware, not to create distortion, because it won't be musical, because we're not reproducing a single tone. In the studio, we may want to use distortion to sweeten up a guitar or something, add character to the sound of a guitar. And in fact, that's one of the major purposes of a guitar amplifier. But you wouldn't want to apply that when it's already been mixed with other instruments. And so it's very important not to add that distortion to a complete musical production. And that's what happens if you try to apply distortion in your playback equipment. Really looking for those transparent playback devices is really what's going to give you the best experience at home. So we put a high priority on that when we're designing products. It's more important to keep the distortion low than even the noise. But we want the product to be noise-free. I'm sitting right next to this speaker. There's not a sound coming out of it, and that's the way it should be. Nothing to distract from the musical performance.